In this session, we're going to look at functions all through and try to answer our function questions. Okay, November 2018, we're starting from here. Question 4, and then we'll go to question 5, and all functions with 2018 quickly in this session. And the diagram below, the graph of f of x equals to ax squared is drawn in the interval x less than or equal to 0. So basically looking at the negative values of x. The graph of the inverse is also drawn, p negative 6 is to 12, as a point on f and r is a point on the inverse. Alright, so p is on f while r is on the inverse. Okay, let's take these questions over to our platform to work. Alright, so we have our platform, and there we go, the question is here. Alright, lovely. Alright, so we do have all of that, and okay, just to make sure we record it. Alright, is f inverse a function? Now, how do you know a function? This is the basic grade 10 strategy of knowing a function. Alright, there are two ways to know a function. Let me just put a note here. To know if something is a function. To know if a given function expression, either a given function expression or a graph, is a function. Alright, there is what you call, the simple one is what you call the vertical line test. This is where a vertical line drawn cuts the graph once, and basically this is known as one-to-one mapping. I'll just quickly, if you look at this, if I were to draw, that's a function. A vertical line would only cut this thing once. Alright? A vertical line will cut this once. And that's what somebody's thinking. Somebody's thinking about a parabola. Yes. If you have a parabola, where's your vertical line? Once. That's a function. But if I have something like this, what happens? A vertical line, that is not a function. Alright, so for every x value, there is only one corresponding y value. Alright, so that's the rule for a function, a vertical line test. Alright, for every x value, which is still one-to-one, for every x value, there is only one y value. Alright, that is what they call a function. So this is not a function because for x value here, but remember it must be a horizontal, a vertical line, not horizontal, a vertical line. Alright, so for every x value, there must be just one y value. If we go back to our question, so the question says, is f inverse a function? Vertical line test? Yes, it is. Vertical line test works. Yes, it works. At any point, yes, it works. Alright? So your answer here is what? Yes. Why? You can just simply write one-to-one mapping. One-to-one mapping. Or you can write the whole expression there, that for every x value, there is only one y value. Right. So yes, it is. Now that is what we introduced in grade 10 when we introduce functions. Okay. Alright, the next question says, I'm going to have to clean this. Alright, so you can pause if you want to make notes quickly, but for me to create space and work effectively, it's better if I just remove my answers. Okay, now the next question talks about if R is a reflection on P in the line y equals to x. Lovely. Read 9 again. Basically, what happens here is if you reflect along this line, if you reflect AB along the line y equals to x, what you do is you switch values. Y becomes x, because that's what we're saying. You see? Y becomes x, and x also becomes what? Y. Basically, that's all. Alright. So, if R is a reflection of P, point R is a reflection of point P, what will therefore be the coordinate of P, of R? It will simply be negative 12. Alright, can you see it's moving further away on the x, and it's higher, negative 6. And we are done there. So those are quick basic function ideas that we need to know. Calculate the value of A. Alright, calculate the value of A. I want to create space here. Calculate the value of A. To calculate the value of A, there must be a given expression of a function. Let's go check. We have f of x equals to ax squared. Alright, so f of x equals to ax squared. Remember, don't forget, when it comes to function, your f of x simply means y. If you keep that at the back of your mind, then the functions become something you can work with easily. Now we have a point negative 6 and negative 12. Remember, it means your y value is what? Negative 12. I'm looking for A. And what is my x value? Negative 6. Now we just do the algebra here. Alright, so what do we do here? Negative 12 equals to negative 6 squared will give me 36A. What do we do? Divide both sides by 36. Therefore, A will be equal to negative 12 over 36, which is equal to negative 1 over 3. Done. Alright, very straightforward. Don't be scared by looking at a function they give you. It's quite scary sometimes when you look at the graph. Don't. Avoid being scared. Take it one step after the other. You would find that it's very doable. Alright. Write down the equation of the inverse of f. Alright. So now we know our A. Let's first write our f equation. Okay, I think I can, so we can actually, can move down here. Our function, our f of x basically is what? Ax squared, remember? So I have 1 over 3 x squared. Okay, and basically this is y. Y equals to negative 1 over 3. Alright, if you want to just make it easier, you can do that. So that the squared is only on the x. Now, when it comes to the inverse, what do? Anywhere you see x, you write y. And anywhere you see y, you write what? X. So what do we have here? X, therefore, equals to negative. X, therefore, equals to negative 1 over 3 y squared. Alright, let's solve that together. Now we're going to need our algebra information here. So already now I am dealing with the inverse. It's important that you just show that you changed the value. So we're going to look for y. And to look for y, what do? We divide both sides by negative 1 over 3. So can I rewrite this? Let me rewrite this. Negative 1 over 3, just for clarity, so that everyone is on board. Divide both sides by negative 1 over 3. Y squared equals to x divided by negative. I'm doing this because you cannot press x on your calculator. Alright, so y squared equals to x times negative 3 over y. What does that give you? Remember the rules. So y squared becomes what? Negative 3x. But what is y? Y therefore has to be the square root of negative 3x. And remember, when you look for the square root of a number, it has to be positive or negative. This is a grade 12 standard. Okay, now, but how do we go further from here? Guys, you cannot look for the square root of a negative number. That means in this case, x cannot be greater than 0. This is wrong. Because if x is greater than 0, then you'll be having a positive value here, multiplying by negative 3. You cannot look for the square root of a negative number. That means our only options here are the fact that x can only be less than or equal to what? 0. So that if x is negative, this negative will multiply this negative and give us what? A positive. Then we can find a positive value. Alright, that's one. Number two, if you look at the graph, let's go back to the graph. Even from the question, I think the question actually mentions that we are dealing with this interval x less than or equal to 0. So we are only dealing with the side. And once we deal with the left side only, we're dealing with the side only. Do you notice that all your y values are also what? Negative. So all your y values are negative. What will then our answer be? All my y values are what? Negative. I am choosing that option. I have negative 3x, but x cannot be greater than 0, so x will only be less than or equal to 0, and that's your answer there. So I hope that works for you. Negative because y values are negative. Negative 3x, we're saying x is less than or equal to 0 because if x is greater than 0 here, we're going to have a negative expression under our square root, and that will give us an error on your calculator. Alright, so that is the whole question 4 done. We're moving on to question number 5 quickly. Alright, so let's create a new page and let's go screen grab question number 5. So this is still November 2018. Let's get question, okay, question 5. Lovely. Question 5. Question 5. Okay. All right, there we go. We have our question in place right now. Here we have a simple hyperbola here. All right, the first question says, write down the domain. Now, what do you know about the word domain? The word domain simply represents what? X values. All right. Now, if you look at this, what are your X values? So you have f of x equals to negative 1 over x minus 1. Now, the whole idea is so that your denominator, this is the whole idea, your denominator must not be equal to 0. Must not be equal to 0. Once you have your denominator equal to 0, then this becomes an error on your calculator. So, x minus 1 equals to 0. X equals to 1. You know what this means? It means when x is equal to 1, your denominator would be what? A 0. So we are saying x, we don't want our denominator to be a 0, so x must not be equal to 1. Because when we say x equals to 1, we're going to get a 0. So what is our domain? Our domain, it's quite simple, just trying to make the explanation very easy for everyone. Domain, therefore, is that x is an element of all numbers, but x cannot be equal to 1. Somebody else can decide to write that x belongs to, you have from negative infinity, all right, to 1, not inclusive. Okay, this is quite complex for some of us. All right, it's a union, not inclusive, 1, all right, to infinity. If you do this here, let's just explain. Some of us like to be fancy. If you do this, then it's wrong, because this block bracket simply means 1 is involved. All right, so this is wrong. So for simplicity, I would rather you stick to the first option. Very straightforward and very simple. All right. But in case you're given something like this in an exam, you must know what it means. This one means up to 0,9, not including 1. So we're just doing that for expression's sake. All right, 5.2. Let's check 5.2. It says write down the asymptotes. Okay, I'm just going to do that right here. My asymptote. Again, asymptote points are error points. These are error points. Where will I get an error? I'll get an error when x equals to 1. All right? And in this case, you notice there's no y expression here. Y equals to what? 0. All right. Let me show you that if y equals to 0, this thing would make no sense. It will make absolutely no sense. You have f of x equals to negative 1 over x minus 1. Let's make y 0. Just to show you, 0 equals to negative 1 over x minus 1. Can we cross multiply? The whole of this multiplied by 0. I mean, this is mathematical jargon. Makes no sense. So that's what I was saying. Our x equals to 1 and our y equals to 0 are our asymptotes. All right, number 3. What are we supposed to do? Sketch the graph for 3 marks. Lovely. Sketch the graph. To sketch the graph, guys, there are rules that you need to quickly follow. So basically, this is the basic thing about functions. If you know this, you can do with any function question. Number 1, draw your asymptotes. All right. Number 2, y-intercept. If you can get y-intercept, or if you can get x-intercept. All right. Let's check quickly with this function. All right. F of x equals to negative 1 over x minus 1. Remember, this is your y value. Negative 1 over x minus 1. Already we have said, how do you get a y-intercept? X must be equal to what? 0. Let's try that. Y equals to negative 1 over what? 0 minus 1. What would that give you? That would give you what? 1. So let's keep that coordinate. X is 0 and y is what? 1. Number 2, x-intercept when y equals to 0. By the way, we don't need to do this because we said this is our what? Asymptote. All right. Now let's go check what our graph would look like quickly. Let's check what our graph can possibly look like. All right. Okay, we have that. Lovely. We have that. Now, our asymptote, remember, y equals to 0. Automatically, this is my asymptote, y equals to 0. And our x equals to 1. All right. Asymptote x equals to 1. Let's just put... Okay, let me do this. X equals to 1. All right. So that's my asymptote. And what point do I have? I have a point 0 and 1. We got that point 0 and 1, which means when x is 0, y is equal to what? Which is somewhere here. What does that tell you? That automatically tells you, look, you are dealing with this quadrant here. And definitely a quadrant. So, what then are we going to have as our asymptote, as our line, as our graph? Remember that your graph must pass through that point. All right, your graph must pass through that point. Okay, so we have 2 asymptotes. The graph would not touch here. Oh, sorry, no, this one is not the asymptote. Our asymptote we said what? X equals to 1 and y equals to what? 0. In fact, to make that clear enough, I want to do something here. Blah, blah, blah. Let me draw a asymptote danger line, saying your line should not touch, your graph should not touch this point. All right? Your graph should not touch this point, asymptote, danger line. Okay, so whatever you draw should not cross those, not touch them. Already we have this point. What does that tell you? My graph should not go across y equals to 0. So my graph should just go this way. It's going to go this way very close here. It's going to climb there, and it's going to come close there. And that's it. All right. And once you draw it in this quadrant, you must reflect it here as well. And you have such a graph there. All right. And here x equals to what? 1. So basically, that is your graph. And this is your f of what? X, which is also basically f of x. All right, lovely. I hope that makes sense. That's how you sketch. The last question, I believe, says, for which values will x multiplied by f prime of x greater than or equal to 0? I'm going to make the graph to work that out. For which values of x, okay, I want to write that here. For which, so we're looking for x values. That's one thing you must quickly remember. We're looking for x values. All right, x multiplied by f prime of x be greater than or equal to what? 0. All right, lovely. Let me just make sure that we're on board. Yes. Now, let's start by interpreting this. That is your first derivative. And what does your first derivative mean? It means the gradient. All right. Good. Gradient. Now, here, we want something that is what? 0 or positive. This is how I like to do this. Okay, I'm going to break this down here. And f prime of x, all right, I want it greater than or equal to what? 0. Greater than or equal to 0. Greater than or equal to 0. Good. It means here I must get a 0 or a positive number. That's all I want. For me to get that, let's go quickly interpret. What does this mean? We said it means the gradient. All right, let's plot a gradient on this graph, because that's what it simply means. The gradient of this graph, a gradient must touch 2 points, remember? All right. That's my gradient. Do you notice that the gradient of this graph would be positive? Let me do something. Please take note and don't be confused. If I draw a line like this, I do not have a gradient because I only have 1 point. What's your gradient? y2 minus what? y1 over x2 minus x1, which means I need 2 y values and I need 2 x values. So if I use this green one, do you notice on my graph I only have 1 point, which doesn't work for me? Keep your eyes on the colors. Using the blue one, I have a x and y value, I have another that, so I can calculate the gradient, which means this is an increasing function. All right, this function here is an increasing function because the gradient is what? Positive. All right, which means for all of this, I'm going to have positive values also. All right, for me to have a 0 here, it means this one must be 0. Is that fine? And this one must be what? Positive, which means x can not be negative, because once x is negative, check, negative times positive will give me negative, and I don't want this. So my possible options are x must be 0 or greater than 0, a positive value. All right, so basically x must be greater than or equal to 0. By the way, x can still not be equal to 1. That we will keep rewriting because that's my asymptote. And we are done with such a question. Alright, so please take note, especially this thing here. Our first derivative simply means gradient. The gradient of this particular one, look, if it's a small thing here, if my graph was like this, then what will your gradient be? Your gradient will be what? Negative. You see that it touches 2 points. You need 2 points. The gradient will be negative. Alright, so that is November 2018. Alright, I hope it has helped so far. November 2018. Next question, question 6, still on the same paper. Alright, so what we'll do is we'll just cut this video after this and then do February 2018, so it's all functions. Alright, we have this. In the diagram below, A and B are the intercepts. Alright, I like reading and checking my graph. A and B are the intercepts, and I have the function given. A straight line, which is G, cuts through point A at C, which is 4 and 5 there, and the y-axis at 0 and 1. Lovely. M is the midpoint. No, sorry. M is a point on F, and N is a point on G. Alright, such that MN is parallel. Okay, that makes sense. MN cuts through X at T. Alright, the first question shows that G of X is equal to X plus 1. Alright, we have it here now. Good. What are we looking for? Show that G of X is equal to X plus 1. Show that G of X is a straight line. Oh, basically that's very straightforward. Equation of a straight line. How do we get? There are different ways. There are different ways of getting such equations, but whichever way, you must calculate the gradient first. Y2 minus Y1 over what? X2 minus X1. Alright, if that's my point 2 and my point 1, we are given this point 0 and 1, which is, so we need just 2 points. Alright, so we can say 5, which is my Y2, minus 1 over 4 minus 0, and that will give us what? 1. So my gradient is equal to 1. My C, we have C, which is y-intercept, is also 1. So y equals to what? Mx plus C. Y equals to x plus 1. Done. That's what they want us to show. But somebody else, might decide, not in case Elena just needs to see that y-intercept, might therefore say y minus y1 equals to mx minus x1. And we can pick any point. Let's pick point 4 and 5. Y minus 5 equals to, remember this is 1, x minus 4. Alright, just in case Elena did not see the y-intercept there. Alright, so y, or in case you're not given, x minus 4 plus 5. Y is, what is 5 minus 4? Alright, good. Calculate the coordinates of A and B. What do you know about the coordinates of A and B? These are my what? X values. And basically, these are x-intercepts. How do you get x-intercept? Y must be equal to what? 0. Alright, let's quickly get that. I make the space so that it's easier. Just want to stay. Now, looking at the graph quickly, this is one of the things that we must learn to do. What type of, or what is the nature of the x values that you are expecting? Do you notice that one must be positive and the other one must be negative? So those are the things you are looking at. One must be positive and the other one must be negative. So if you do not get positive and negative, you've done something wrong. Now, what's your function? What's your function quickly? Y equals to x squared minus 2x minus 3. Do you think we have factors here? I see factors. Y. Okay, so here we cannot say y. Y must be equal to 0. Alright, so we're saying x squared minus 2x minus 3 equals to what? 0. Okay, I don't know if you see factors, but I see a 3 and a 1. Alright, 3 and 1. But I want a negative 2, so I need a 1 minus 3. So x, alright, equals to 3 here, or x, remember we said you must have two values. Alright, good. And we already know our y values here. Our y values here are what? 0. Our y value is 0. So my x is what? Negative 1 and 0. And this was 3. Please, the question says coordinate, so you must write it as a coordinate. A, negative 1 and 0. B, 3. Alright, see, these marks are for every learner. Determine the range of f. What does range mean to you? Range simply means what? Y values. And if you notice, look at your graph. Where does your y start from? Your y actually starts from here, going up. All of these are your y values. But from here, what is this point? This point is your turning what? Point. Now, how do you get turning points quickly? Okay. How do you get turning point? There are 2 ways, 3 ways that we know to get the turning point. Okay. Number 1 way is to find, because your turning point is the symmetric point between the 2 x-intercepts. So you could actually say x1 plus x2 over 2. What are your x values? Negative 1 plus 3 over 2. And that should give you, do you notice this is on the positive side? So your x should be positive. 3 minus 2, which is 2 divided by 2, 1. Alright, your x is 1. Or you can simply say, let's clear this quickly, just in case somebody else wants to. Remember, we're doing all of this to revise. X equals to negative b over 2a. Negative. What is our function again? Our function is x squared minus 2x. Okay, let's put down here. Minus 3, which means our a is 1 and our b is what? Negative 2. Alright. Remember now this is negative and that's our b, which gives us what? 2 over 2, which gives us what? 1. Alright. And the third way, quickly, the third way is that your first derivative must be equal to 0. So here we're dealing with calculus quickly. Alright, 2x minus 3. That's the function. So what's our f prime of x? I'm sure you can quickly do that. It's 2x minus 2 equals to 0. 2x equals to 2 and x equals to 1. Do you see we have the same values? Now, but we need the y value because that's the range. So what is our y value? Y will be equal to the substitute whatever x value you get into the original equation. Alright, and this will give you 1 minus 2 minus 3, and this will give you what? Negative 4. Alright, so this point here is negative 4. So do you notice my answers are all above negative 4? So what is your range? Y must be greater than or equal to what? Negative 4. That's your range. Lovely. Lovely. Okay, quickly, the next one. The next one. I know you do have this question.
Sorry, I don't know how to help with that yet.
I know we have these questions, so we will just erase this so that we can then deal with this together. If mn, okay, I think I'm going to need my whole graph. If mn, alright, this distance here, good. If mn is equal to 6 units, that's what we have. If mn equals, determine the length of OT, alright? Determine the length of OT if t lies in the negative x, alright, it lies in the negative x, show all your working. Okay, if you look at this, they said if mn is 6, What are we looking for? We are looking for the length of what? OT. By the way, remember that this is parallel, so you must think about that as an angle 90 first. Okay, think about that. But that is 90. That makes it actually parallel. All right. But what do you notice? What do you notice there? We have this function, x plus 1. Is that okay? Okay, I think I need to get a fresh page. All right, look at this. We have this page. I want to work on this page afresh. We have x plus 1, and we have this function x squared minus 2x minus 3. All right. Basically, what I want is I want OT. Now, my challenge here. All right. Look at this. We are given that this thing here, this length here is 6 units. Now, what does this mean to you? This point here is a point where this line, that's my function, and that's my function. If I were to trace this value, I want the length of this line. I want you to see where I'm going. This function here, basically I am looking for the y value of the parabola and the y value of the straight line. The distance, you see the distance represents the difference between the parabola and the straight line, the difference. Basically, can I therefore say that mn, now if you understand that, then we will be good. Mn therefore is equal to the difference between the two, f of x minus g of x. Because f of x, that's it. The y value, the distance here, can you see the distance here is actually equal to the distance here. Alright. So the difference between the two will give me that. So mn equals to f of x minus g of x. Let's go check something. So mn, I'm going to write it here, equals to f of x minus g of x. My mn is what? 6. What is my f of x? X squared minus 2x minus 3. And what is my g of x? X plus 1. Please, a bracket is needed. Alright, what do we have? 6 equals to x squared minus 2x minus 3 minus x minus 1. Alright, x squared, what will this give us? Minus 3x minus 4 equals to 6. Standard form. We need to change this into standard form by taking this one to the other side. X squared minus 3x minus 4 minus 6. Now plus. Minus what? 6. Does that work for you? Alright, so what do we have? X squared minus 3x minus 10 is equal to 0. Do you see factors? I see a 5 and a 2. Alright, x, 5, and 2. Remember, I want a negative 3, so I want that. So my x would be equal to what? Either 5 or my x should be equal to what? A negative 2. But we are told that, so we're looking at x values. So we got x. That means we want the x value here. Oops, sorry. We want the x value. We're actually looking for the x value here. And we got what? X equals to 5 or negative 2. But remember, we are told that x lies in the negative. That's what the examiner wants that. So the correct value is x equals to what? Negative 2. My x equals to 5 is not applicable. Alright. So this is the correct one. This one not applicable. Now, let's go back to the graph quickly. If this is negative 2, what is the length of OT? OT is what? 2 units. Alright, lovely. OT therefore is 2 units. Okay, let's go to the next question. I hope that makes sense. Let's go to the next question. 6.442. Hence, write down the coordinate of n. write down the coordinates of n. Let me take it back to that graph. So we want the coordinates of n. Let's clean this. We want the coordinates of n. By the way, I already know that my x value there is -2. What do you notice about n? N is a point on the straight line. And my equation of a straight line is that. So how do I get my y value? I substitute. What value am I substituting? Negative what? 2 plus 1. What is that? -1. So what is my n value? X is -2 and y is -1. Done. Alright, so what function is about what you can see. And you must learn to see well. 6.5. Let's go. What is 6.5 saying? Determine the equation of the tangent to f. Alright. Equation of the tangent to f parallel to g. Now, let's check something. Equation of a tangent is a straight line. A tangent, so basically we're looking for y equals to what? mx plus c. I want to quickly explore. Alright, I think, let me just do this on this page. So when we talk about a tangent, the first thing that comes to your mind is, what does a tangent look like? A tangent is a straight line. A tangent is a straight line. Alright, a tangent is a straight line. And for me to get a straight line, I need the gradient. Now, this is bringing calculus into the whole thing. When we talk about calculus, the first derivative is equal to gradient. The first derivative, alright, is equals to the gradient of the tangent. Alright, so do we have our function? What's our function? F of x equals to x squared minus 2x. Is it minus 3? Let's just check to make sure. Yes, minus. Now, what is our first derivative? Remember, we said first derivative will equal to the gradient. All right. F prime of x is equal to 2x minus what? 2. Let's pause there. Now, they said it is parallel. So, my tangent is parallel to g. What do we know about parallel lines? They have equal what? Gradient. It means that this f prime of x, the which is equal to the gradient, is equal to 1. How do I know it's 1? Remember, equation of g is what? X plus 1, which means our gradient is what? 1. Therefore, 2x minus 2 equals to 1. 2x equals to what? 3. X therefore is 3 over 2. Alright, so the point I am going to be dealing with is actually having, the point of intersection is actually at 3 over 2. What do I need to do to get my y value? I substitute that back into the original what? Equation, because it said equation of the tangent to f. So what is my y value? Remember my f of x? Okay, don't let me write that way. Let's make it just so we simplify the whole thing. Already I know my x value. F 3 over 2 therefore will be equal to what? 3 over 2 all squared minus 2, 3 over 2 minus 3. Alright, so let's check what our answer would be. Let's have a bracket there. You have 3 over 2. We close the bracket. And then it's all squared. Minus 2 into bracket. So you're just doing like what a learner would do in an exam. Alright. Minus 3. So that you familiarize yourself with it. It's negative 15 over 4. Negative 15 over 4. So my y value is negative 15. Alright, so what do I have right now? I have my x value, I have my y value, and they said the line is parallel. my gradient is equal to what? 1. Is that fine? So how then do we get the equation of the line? All right. So can we then say y minus y1? Y minus y1 equals to mx minus x1. Y minus negative 15 over 4, remember. What's my gradient? 1. X minus, what is my x1? My x1 is what? 3 over 2. Okay, so y plus 15 over 4 equals to x minus 3 over 2. Y therefore equals to x minus 3 over 2 minus 15 over 4. Alright, if you use your calculator, you are going to get x minus 21 over 4. Alright, we could work without a calculator because if you multiply all of this by 2, it gives you 6. And 6 minus 15, minus 6 minus 15 gives you negative 21. Alright, so that's the equation of the line. But please use a calculator to get your answer there. Lovely. So that's the equation of that line. Now, the next question says, okay, for which values of this function and the straight line x plus k, for which values of k will x squared minus 2x minus 3 and h of x plus k not intersect? I want us to do something here quickly, just to make this. Okay, I do have another page for us. By the way, what's the equation of this line? Y equals to what? X minus 21 over 4. Alright, I want this. So that it's simplified. And this is the way I want you to see your functions when you do this. You know, it's your paper. Feel free to write on it. There's no point having a very clean exam paper when you're done. Doesn't make sense and you're struggling. No. You can see what I did on my... So use a pencil so you can clean in case you need to redo something. Alright. We got an equation that says, what was the equation? Y equals to x minus 21 over 4. What does this tell you? My C value, right? Negative 21 over 4. Let me clean this. Do you remember this value? Alright. That value was what? Negative 4. That value was negative 4. Okay. Now, I want us to draw this line. 21 over 4 would simply be, you have 5 somewhere there. Alright, it's greater than 5. So because 21 divided by 4 would give you 5 point something there. Alright, so that point, actually, that point is, let me look for a blue, that point is somewhere here. Okay. That point is somewhere after 4, okay? Just trying to estimate the calibration. That point is somewhere there. And our x value was what? 3 over 2. By the way, let's just quickly, I want to write all the points so that it's easy for us. This is negative 1. This is 3. Our midpoint here, we said our midpoint was 1. Now, what is this? 3 over 2, which is 1 comma 5. So if this is 2, then our 1 comma 5 is somewhere here. Lovely. Good. So if I were to, I'm just going to try to draw a straight line so that it's easy for us to see. I'm going to try to draw a straight line here, which would be a tangent. There we go. All right. Close enough. Close enough. because it is parallel. It must be parallel to this. Remember, it is both 1 and 1. It's both 1. Gradient here is 1. Gradient here is 1. Okay. All right. And this point here is what? Negative 21 over 4. All right. Negative 21 over 4. It must, you can just confirm that. All right. 21 divided by 4, that will give you 5.25. All right. So this point is 5.25. So that's why you see it's below 4. Now, the question says, we want a line. Listen, we want a line x plus k. Do you notice that the gradient of this line is also 1? So that these two lines, this line and our f of x, will not what? Intersect, which means they will not touch each other. This is the only point of intersection. Now, for them not to touch each other, let's see something here. For them not to touch each other, which must still have the same gradient, all right? It must still have the same gradient, and they mustn't touch each other. This line must actually come here. Okay, I want that. This line must actually be here. Do you notice these lines are parallel? But what do you notice? Yes, they are parallel. The fact that they are parallel means that my gradient is equal to 1 there. What does k stand for? That's my y-intercept. Do you notice that my y-intercept is any number below 21, or below negative 21 over 4? Because whatever line I draw will always be below that line. Can you see that the straight line, the red line, and my parabola are not intersecting? Therefore, what is my k? My k can be any value, but that value must be below 21 over what? 4. Less than negative 21 over 4. Done. Functions. Done in this question. November 2018 functions. I hope you enjoyed this session. You'll get the February 2018, and I just work on functions all through in a series of videos. So this is functions part 1. I hope this makes sense. Learn to draw, learn to analyze, learn to see. It really does help, and learn to interpret that x plus k. So rewind it and rewind over and over again until it makes absolute and perfect sense to you. All right, good luck as you prepare for your final exams. Thank you very much.